So here we're going to be verifying this trig identity. The first thing I'm going to do is label each side as the left-hand side and then this side as the right-hand side. And I'm going to walk you through a process that you could use to verify most trig identities. So the first thing that I'm going to do is try to choose the more complicated side. I'm going to put that in quotations because, of course, that's a little bit subjective. Sometimes it's really obvious which side is more complicated. And other times they're pretty similar, and so it probably doesn't matter which one you choose. Here, I'd say that the right-hand side is more complicated. Then my second step, which a lot of students like to do this, and I do think it's a good idea because a lot of students remember the sine and cosine identities better than any of the others. And so they change everything into terms of sine and cosine. Now, because of this step 2, I'll mention that this might not be the shortest or easiest way to solve this problem, but it will work. So by changing everything into sine and cosine, it might make the solution a little bit longer, but it's not necessarily a bad thing. And the third thing we're going to do is try to simplify as much as we can. Okay. And the last thing, first of all, I'm going to ask, after I've simplified, am I done? Say I start on the right-hand side, I do all these manipulations, and I end up with 1 plus cosine x over 1 minus cosine x. Then I would be done. But a lot of times that's not the case. So if it's not, then I'm going to see if I can use any identities that I already know are true. For example, we have the Pythagorean identities, the reciprocal identities, the co-function identities, double angle identities. We have a few different identities that we could use. I'd say the most popular one is the Pythagorean identity. It gets used a lot in these, but you never know. And then after I use my identity, I'll probably have to simplify, and then I'll ask again, am I done? And kind of go through that process all over again. Okay. All right, so let's get started. I decided that I think the right-hand side is the more complicated side. And so that's the side I'm going to roll with to start. I'm actually going to write this down again because I want to be able to refer to it. So we have 1 plus cosine x over 1 minus cosine x equal to cosecant x plus cotangent x squared. Again, I called this my right-hand side. I called this my left-hand side. Now I am going to start with my right-hand side, and that is the only thing I'm going to work with. But that doesn't mean that we should just forget about the left-hand side. We do know that this is the goal we have in mind. So as we're manipulating the right-hand side, you're thinking, okay, but what do I want it to look like? Okay, so let's go ahead and get started. So my right-hand side is equal to cosecant x plus cotangent x squared. And this was step 1, right? Just choosing which side I think is more complicated. Then my step 2 is to change everything into terms of sine and cosine. So using the reciprocal identity, we know that cosecant is 1 over sine x. And cotangent is cosine x over sine x. Okay. So that's my step 2. And then I'm going to want to simplify as much as possible. So the first thing I notice that we should immediately notice is that these two fractions have the same denominator. They have a common denominator. And so I can go ahead and add these two fractions. Okay, there's one simplification step. And now I certainly am going to have to square it. Once again, look at my right-hand side and look at my left-hand side. I don't have any squared terms over here, so I do need to square this out. So I'm still in step 3. I'm still simplifying. So if I square the denominator, I get sine squared. But when I square the numerator, I'm going to be careful. I could actually square out, 1 plus cosine x times 1 plus cosine x, right? This would be 1 plus cosine x times 1 plus cosine x. And I can go ahead and, FOIL and get an actual answer here. But do I really want to do that? When I look at my left-hand side, I see that I actually want 1 plus cosine x to stick around. And so I'm going to say, you know what? I'm going to keep it. And I'm just going to put 1 plus cosine x, 1 plus cosine x, because I don't want to make things harder on myself. And there's more simplification. Now I've basically completed step 3. I've simplified as far as I can. I ask myself, am I done? No, I'm not. It does not look like the left-hand side. And so I move on to step 4, which is, are there any identities that I should use? Once again, let's take a look. I want to have a 1 plus cosine x in my numerator. I have that, so that's great. I also want to have a cosine in my denominator. Well, I don't have that right now. I have a sine. So what identity could I use to change this into something in terms of cosine? Well, I could use my Pythagorean identity. I know that sine squared x is equal to 1 minus cosine squared x. So here's my step 4, where I utilize an identity. And now we're really, really close to being done. All I need to do is figure out how to cancel out one of these 1 plus cosine x's. So I move back to step 3, which is my simplification step. I'm going to leave my 1 plus cosine x, 1 plus cosine x. And ask myself, okay, how can I pick up a 1 plus cosine x in the denominator? Well, this denominator is actually a difference of squares, right? 1 is a perfect square, and cosine squared is a perfect square. So I can write this as 1 plus cosine x, 1 minus cosine x. And what do you know? Cancel a 1 plus cosine x. I'll simplify a 1 plus cosine x with this 1 plus cosine x. And what am I left with? I'm left with 1 plus cosine x over 1 minus cosine x, which just so happens to be my left-hand side. And so I have successfully verified the identity.